Our next speaker is coming from Epignosis. He's dedicated to fostering a collaborative team environment, and his speech is about revisiting user registration and authentication. We'd like to welcome on stage Vassilis Poursalidis.
Thank you very much.
Thank you.
Hi, Vassilis, stage is yours.
Thank you. Okay. Now, I will go back to the boring stuff, right? I will go back to the entry of your application. Every application has an entry point. This is the first line of defense. And this is your user registration and your user authentication. Anyone that has developed any web app, any sort of web app, has done this, has somehow managed to register users and then let them log in to their application. There are a lot of solutions out there that delegate this process, like SSO, OpenAuth, but every web app has stayed with the default built-in user authentication and user registration for a long time. Maybe it stays there forever. So I would like this to be a focus point when you build your next application, or even go back to your current applications and revamp them. But before we continue, let me introduce myself. I'm Vassilis. I'm engineering director at Epignosis. Epignosis is the company behind Talent LMS, a product that is a learning management system used by many users worldwide. Now, let's see what we will talk here. First of all, we'll talk about cryptographic protocols. We'll not go into the details, don't worry. We just need to know them, because if we're going to use them, we need to know how they work in a general sense. First of all is proof of work. This is quite simple. There, I give you something, a puzzle, and then I expect from you to respond to this puzzle. And the second part is zero-knowledge password proof. This is a protocol that you can get from me, that I know the password without ever revealing the password to you. And what this helps us with? The first part, proof of work, will help us to rate limit our application. So it will help us during user registration. But since any API call, like our registration, we can also rate limit our entire application, high-risk methods, lower-risk methods, and so on. And the second part will help us with user authentication. It will help us during registration, and it will also help us during the login procedure. And the idea behind this is to enhance the solution of our application. And of course, the utmost goal is for me to show to you, and also to be able to integrate those solutions to web frameworks, the ones that we use. Because every web framework has a built-in functionality for user login and for user registration. And I want these protocols to be embedded there, because the security that they offer is much greater. So, how everything starts? Well, you have a great idea, but you don't want to be bothered by user registration and user authentication. You want to get over with it. It's not your primary domain, it's a secondary domain. So you delegate this either to the framework that you have chosen, or you build something on your own. And you are also very aware of things can go wrong. So what do? You may impose rate limiting. You may impose CAPTCHA in order to fend off automated bots. Or if you're fancier, you can go with a WAF or a bot detection service. But most of the time, it's too early. You will do nothing. You will say, it's not my problem yet. I can think of it later on. I don't have to do anything. Let's just go with the idea. We're not even sure if it will succeed. We don't know anything. So let it go. But, of course, you have done your homework. Either if you have something ready from your web framework, it's OK. But if you implement it on your own, you know that you have to hash passwords. But keep in mind that passwords, plain passwords, travel from your application, from your front end, from your UI, to the servers. And even though you use SSL, any kind of encryption, at the end, you have SSL termination, and from that point on, the password goes unencrypted. So you didn't do your best. And now, let's meet Elliot. This is our threat actor. We will assume that he's not that capable. He's tech-savvy, yes, but he's not like an elite hacker. What he can do? He has a lot of time. He has a lot of resources, and what he will do is try to hack your site in many ways, like registering for multiple accounts, like hacking into other legitimate accounts, like brute forcing on your login screen, and also perform active attacks on the infrastructure. This will play on later when I spoke that you have SSL termination, and then he can also try to receive unencrypted data. But what can we do? Is Elliot unstoppable? No. Everything is a risk factor. You have to account for the risk and calculate the risk that you are willing to take, and then adjust accordingly. And the solutions that I propose, proof of work and zero-knowledge password proof, give us a lot of security. They allow us to do things that by default are not there, and without that much effort. So let's go first. Proof of work. It's a cryptographic protocol where I give you a puzzle, and as I said, you have to solve this puzzle. What solving means? Solving means memory, CPU, or disk. And then I can increase or decrease the amount of computation I want dynamically. And what I do is, when I say dynamically, I mean that I present to you a harder puzzle. And you do that exponentially. So maybe it's easier to start, but as I increase the complexity, the time that you want, or the memory, or the storage that you want explodes. So it becomes very difficult. The nice thing about proof of work is that if I'm a legitimate customer, then I will get degraded performance, but not actually degraded performance. I will see it as degraded, but actually I am pressed to solve a harder puzzle. But again, as I only try to solve it once, it will be easy for me to access your service. On the other hand, the one that tries many times will be hard for him. Now, the zero-knowledge password proof is a protocol again that again has a prover and a verifier, where I present to you during registration with a verification function, and then when I try to log in, I do not give you my password. I give you a verification number that you can easily detect and then allow me to access the service. So let me go back to proof of work. As I said, it can be used very easily for rate limiting. For example, we have APIs that we consider high risk. What are those APIs? Registering credit card, purchasing a subscription, registering for user accounts, anything that can be brute forced by external parties. And when I say an API, I mean that these are automatically. Let me give you an example. Now, in order to fend off bots, I have to use CAPTCHA. CAPTCHA is not at all accessible. Also, CAPTCHA is a puzzle for a human. And since our APIs can be machine to machine, we don't want this. But on the other hand, there are not that much solutions out there. And what I'm saying here is that you can have a machine-to-machine solution where you can easily make it harder for the other party to use your API without giving you some proof that he deserves to be there. Okay? Now, let's go with an analogy. The analogy is that you come to my house and you want to enter on the front door. What I can do to you is I can present you with a scrambled 3x3x3 Rubik's Cube. And I can tell to you, please solve it in order for me to allow you to enter. You take the cube, you solve it, and then you present it to me. From the analogy, it's obvious that solving the cube is very hard. On the other hand, as I can verify it quite easily, it's very easy for me. So I don't do any computational hard effort. Now, what is the risk factor here? No, based on the risk factor, what can I do? I can present either a 3x3x3 Rubik's Cube, or I can present to you a 33x33x33 Rubik's Cube. This is the analogy of the hard work we have to do. And as I said, normal guests that are not doing something problematic can easily solve this type of cube and go on. So, what is a proof of work protocol? A proof of work protocol is, for example, Hashcash. This has been in the books, in the literature from 2003. in 2002. It was introduced as a method to fight spam in a paper back then, and then it was taken by cryptocurrencies and has been used largely for proof of work in order to attach to the blockchain an additional block. And the one that does it first gets the mining resources. So how does this work? It works in the following way. I present to you some data, so the server will send some data to the client, and the client has to select a nonce. The nonce can be chosen through various ways. One way is random or sequential. How do I check the difficulty? I ask you that in order for me to consider this as a legitimate answer, you have to give me back a response with delta zeros at the beginning of the hash. And of course, you hash the data with a nonce in order to produce a result. And based on this, every increase in delta, for example, if I select 10 zeros at the beginning, this is like 2 in the 10th power difficulty. And I can increase this in order to make it much more difficult for you. How does this work? Well, as I said, we have the app and the service provider. As you will see, the first request challenge is optional because it can piggyback with other communications during the API. For example, attach it as a meta. And then you have to, I will have to assess the risk in order to give you back the delta, and in order to protect everything, I combine all this to a Java Web Token, where we have also expiration date, and the delta is protected. Then you come back with this response that you have mined, for example, and then I can easily verify this protocol. I have also prepared a demo. I hope the video works. No. No. No, it doesn't work, I think. OK, what I have here, I have set up a demo where the speed meter, it's not that clear, sorry for that, displays that I'm receiving, I can calculate many proof of works at a given point. And then, as I increase the difficulty, the speed drops, and also the average time for every response gradually increases. Sorry for this. Now, let's go back to the second protocol that I discussed, where we want to transform the user credentials. And this is the zero-knowledge password proof. A specific protocol that belongs to this category is password-authenticated key agreement. These protocols, we have to be very careful there because there are a lot of patents in the area, but there are protocols that are readily available and can be used. The analogy here, as I did with the Rubik's Cube, is the following. There is a where is Waldo poster, and you know where Waldo is. So you can imagine the illustration like they are all applicable passwords that I can choose for them. And then my password is Waldo. When I want to, again, enter the house, like accessing your service, I get the illustration, and also I get a big whiteboard that has a pinhole in the middle. I can move the illustration in order for you to be able to see where Waldo is. But at any point, if I give you just the illustration, you cannot say apart where Waldo was. So there was no, I did not reveal the password to you. Now, one such algorithm, a fake algorithm, is SRP6A. This algorithm is free of patents, is widely used, and has many implementations in many languages. The idea is that during the registration procedure, the initial procedure, I create an ephemeral key, a user salt, and a password verifier. And I give this information to the servers. This is during registration. Now, when I try to log in, I present the username and ephemeral key that I have created during this procedure. And I send them to the service provider. The service provider returns my user salt and then second ephemeral key. I use my password and the two ephemeral keys in order to compute a strong session key. Then I give that back to the service provider, where he computes with a password verifier the same procedure, but with the ephemeral keys and the password verifier, not the password. If the two messages that we exchanged match, then that means that I know the password. If they didn't match, then the access is denied. Now, as I said, if we use those protocols, the security of our solution will be greatly enhanced. There is no transfer of information on the wire about the user protocol. Also, these protocols are cryptographic protocols, so they can be very hard to brute force. And finally, the idea behind those two protocols is that can be added not at the beginning, but also we can add it at a later stage. But you have to bear in mind that security must be in from day one. So, as I said, proof of work, a method to protect resources, zero-knowledge password proofs as a way to help us register and login users. What I want, as a final note, is to be aware of these protocols and give them a second thought the next time you try to do built-in authentication. Thank you very much.
Thanks, Vassili.
Thank you very much.
I don't think we have time for questions, but it was very interesting, really.
Thank you very
much.
So, will you stay for the after party?
Yes.
Okay. So, if for any questions, we can reach out to you later on.
Thank you.
Yeah. Thanks a lot.